Hello everyone, this is Chinnaiah Kalpana here. In this video, we are going to solve a differential equation using variation of parameters part 2. So in this video, we are going to find a dash and b dash using formula. Okay, so let's get going. Solve y double dash plus 4y equal to 4 secant square 2x or d square y by dx square plus 4y equal to 4 secant square 2x using variation of parameters method. Given differential equation, y double dash plus 4y equal to 4 secant square 2x. Right? Consider it as equation. Okay, let it be. Or here we are given a differential equation of order 2, right? Here y double dash is nothing but d square y by dx square. Y double dash or y2 is nothing but d square y by dx square. Now we can write this equation as d square y by dx square plus 4 into y equal to 4 secant square 2x, right? Now I'll write d square y by dx square as capital D square y, that is in differential operator form. Here capital D is a differential operator, right? Plus 4y equal to 4 secant square 2x. Now take y common from these two terms, we'll get d square plus 4 into y equal to 4 secant square 2x. Consider as equation number 1, which is in operator form f of d into y equal to some function of x. I'll write the RHS part as some r of x for my convenience, okay? And here f of d is, where f of d is d square plus 4. And the homogeneous equation of one is d square plus 4 into y equal to 0. Right? Consider as equation number 2. Now we'll find the solution of equation 2 using auxiliary equation, and from that auxiliary equation we'll get the general solution of equation 1 or the given differential equation. Okay? Equation 1 is nothing but the operator form of equation, given differential equation. Okay? The auxiliary equation is f of m equal to 0, where f of m equal to, we are having f of d, which is d square plus 1. Let's replace differential operator by m, so that we'll get f of m equal to m square plus 4. Now the auxiliary equation becomes m square plus 4 equal to 0. Now we need to find the roots of this equation, so we'll take plus 4 to RHS, we'll get m square equals to minus 4, then m equal to plus or minus square root of minus 4. Now we'll write minus 4 as minus 1 into 4. Now split the square root as square root of minus 1 into square root of 4. Since square root of minus 1 equal to I, so we'll get plus or minus I into 2. Therefore, m equal to plus or minus I 2. We know that when m equal to a plus or minus ib, here the roots are complex conjugate, okay? Now coming to the solution of homogeneous equation. When m equal to a plus or minus ib, the solution of homogeneous equation will be y equal to e power ax into some constant into cos bx plus another constant into sin bx. Right? In case of a0, we'll get e power 0 into x, which is e power 0, right? Since we know that e power 0 is 1, so you'll get 1 into c3 cos bx plus c4 sin bx, right, which is equals to c3 cos bx plus c4 sin bx. Now compare plus or minus I2 with plus or minus IB. Then for b equal to 2, we'll get the solution of the homogeneous equation 2. The solution of homogeneous equation or equation 2 is y equal to c3 cos 2 into x plus c4 sin 2 into x, right? That is b equal to c3 cos 2x, y equal to c3 cos 2x plus c4 sin 2x. This is the solution of equation 2. Now just replace c3, c4 parameters with functions of x, a and b, which will be the solution of the given equation or equation 1. Okay, let's see that. Let y equal to a cos 2x plus b sin 2x be the general solution of one or given differential equation. Okay, where a and b are functions of x. If you compare this equation with au plus bev, we'll get u equal to cos 2x and b equal to sin 2x, right? Already we have written the given differential equation in operator form f of theta into y equals to some r of x. So here we'll get r of x equals to 4 secant square 2x. Right? Now we'll find a dash and b dash, which is given by a dash is given by minus v into r of x by uv1 minus vu1, and b dash is given by u into r of x by uv1 minus vu1, and later we'll find a and b using a dash and b dash, and we'll put it in the formula. Okay, consider it as equation 3 for our convenience. We'll consider it as equation 3. Now we can notice uv1 minus vu1 in both the formulae, right? So let's now find uv1 minus vu1 firstly. Which is nothing but u into v1 is nothing but derivative of v dash, and u1 is nothing but derivative of u. Okay, is equals to u. What is u here? U is cos 2x into derivative of v minus v into, what is v? V is sin 2x into derivative of u, derivative of cos 2x with respect to x. This is equals to cos 2x into derivative of sin 2x with respect to x is 2 cos 2x minus sin 2x into derivative of cos 2x with respect to x is minus 2 sin 2x. This is equals to 2 into cos 2x is cos square 2x, minus into minus plus 2 into sine 2x into sine 2x, sine square 2x. Or we can write it as 2 sine square 2x plus 2 cos square 2x. Now take 2 common from these two terms, you will get 2 times sine square 2x plus cos square 2x, right? Since sine square theta plus cos square theta equal to 1, so we'll replace this term with 1, you'll get 2 into 1, which is 2. Therefore, uv1 minus vu1 equal to 2. Now coming to a dash and b dash. Now we'll find a dash using the formula minus v into r of x by uv1 minus vu1, right? Since we know that a dash is nothing but, okay, let it be. Firstly, we'll find a dash, okay, is equals to minus v. What is v here? Sine 2x, and r of x is 4 secant square 2x by uv1 minus vu1 is 2. This is equals to minus 4 by 2 into sine 2x into secant square 2x, right? Which is equals to minus 2 into sine 2x into, we can write secant square 2x as secant 2x into secant 2x. Now we'll replace 1 secant 2x with 1 by cos 2x, because secant theta is equals to reciprocal of cos theta, okay? So we'll replace this with reciprocal of cos 2x into secant 2x. This is equals to minus 2 sine 2x into 1 by cos 2x is sine 2x by cos 2x, which is tan 2x, right? Since sine theta by cos theta equal to tan theta, this becomes minus 2 tan 2x into secant 2x. So we got a dash now, right? A dash equals to minus 2 tan 2x into secant 2x or secant 2x into tan 2x, right? Now coming to b dash. B dash is given by u into r of x by uv1 minus vu1. So let's substitute u r of x uv1 minus vu1. We'll get u cos 2x into r of x 4 secant square 2x by uv1 minus vu1 is 2. This is equals to 4 by 2 into cos 2x into secant square 2x. This is equals to 2 cos 2x into, we can write secant square 2x as secant 2x into secant 2x, okay? Now I'll replace 1 secant 2x with 1 by cos 2x. Since secant theta equals to reciprocal of cos theta, right? Now we can cancel cos 2x. So we'll get b dash equals to 2 secant 2x. Let's now find a and b using a dash and b dash. Firstly, we'll use a dash equals to minus 2 tan 2x secant 2x to find a. We know that a dash is nothing but derivative of a with respect to x. Now let's separate the variables. In order to separate the variables, we'll take the differential dx to RHS. Then we'll get dA equals to minus 2 tan 2x secant 2x into dx. Here the variables are separable. So let's perform integration. Since we know that integral d theta equals to theta plus integral constant c, and integral secant ax into tan ax dx equals to 1 by a secant ax plus integral constant c. Then the above equation becomes integral dA, a equal to minus 2 into, for a equal to 2 we'll get 1 by 2 into secant 2x plus integral constant c1. If 2 gets cancelled, we'll get a equal to minus secant 2x plus c1. So we got a, therefore a equal to minus secant 2x plus c1. Let's now find b. We'll find b using b dash equal to 2 secant 2x, right? We know that b dash is nothing but derivative of b with respect to x. Let's now separate the variables. In order to separate the variables, we'll take the differential dx to RHS, then we'll get db equal to 2 secant 2x into dx. Here the variables are separable. So we can perform integration. Since we know that integral d theta equal to theta plus c and integral secant ax dx equals to 1 by a into log mod secant ax plus tan ax plus integral constant c. Then the above equation becomes integral db is b equal to 2 into integral secant 2x dx. Just compare integral 2x with, integral secant 2x with secant ax, then for a equal to 2 we'll get 1 by 2 log mod secant 2x plus tan 2x plus integral constant is c2. Here 2 gets cancelled and we'll get b equal to log mod secant 2x plus tan 2x plus c2. Okay, therefore b equal to so we got a and b. Let's now find the general solution of the given equation, or equation 1 using equation 3. The general solution of the given equation or equation 1 is given by y equal to a cos 2x plus b sin 2x. Let's now substitute a and b here. We'll get y equal to a minus secant 2x plus c1 into cos 2x plus b log mod secant 2x plus tan 2x plus c2 into sin 2x. From this we'll get y equal to minus secant 2x into cos 2x plus c1 cos 2x plus sin 2x into log mod secant 2x plus tan 2x plus c2 sin 2x. Right? Now we can replace secant 2x with reciprocal of cos 2x. This becomes y equal to, since secant theta equal to reciprocal of cos theta, we'll replace secant 2x with 1 by cos 2x into cos 2x plus c1 cos 2x plus sin 2x into log mod secant 2x plus tan 2x plus c2 sin 2x, right? Here cos 2x gets cancelled and we'll get y equal to minus 1 plus c1 cos 2x plus sin 2x into log mod secant 2x plus tan 2x plus c2 sin 2x. Or firstly write the terms involving c1 and c2. We'll get c1 cos 2x and c2 sin 2x minus 1 plus log mod plus sin 2x, right? Sin 2x into log mod. Sin 2x into log mod secant 2x plus tan 2x. This completes the problem. So we have seen the variation of parameters, I mean the differential equation using variation of parameters problem in the other way, and we'll see the last method, finding integral a and integral b, or finding a and b in the next part. I hope you'll understand. We'll see you in the next video. Until then, bye bye.